So today we're going to look at the sum and difference rules for differentiation. And these rules have come from the sum and difference rules that we used in our properties of limits unit. So they're very, very similar. So the sum rule is just that the derivative of a sum is the sum of the derivatives. So that just means that if both f and g are differentiable, then f plus g is also differentiable. So if I were to add these two functions together and take the derivative, that's the same thing as taking the or individual derivatives. The difference rule is exactly the same, except it's a difference instead of an addition. So the derivative of a difference is the difference of the derivatives. And if both f and g are differentiable, then f minus g is also differentiable. And we can do that one of two ways, either by taking f minus g first and then taking the derivative, or taking the derivative of each and keeping them as independent functions. So this we can carry on to look at multiple terms, just doesn't have to be just the two of them. So let's have a look at some examples. So question 1, find the derivative of 4x to the power of 3 plus 3x square root x. So my first function here, I bring down my exponent and I reduce my exponent by 1. Second function, I bring down my exponent. Remember, the exponent here is actually 1/2. And I reduce my exponent by 1. Now I'm just going to clean this up so it's in a little bit of a cleaner form. Okay, remember my negative exponent goes onto the bottom. Okay, all right, number 2. Keep my coefficient, my constant, bring down my exponent, reduce my exponent by 1. Keep my coefficient, bring down my exponent, reduce my exponent by 1. Keep my coefficient, bring down my exponent, reduce my exponent by 1, and this term becomes just 0. I lose it. Okay, let's clean that up. Okay, so we can apply this idea to any number of terms. Okay, here's a couple more. Okay, so first I'm going to actually expand this out because I know a sum and difference rule. I don't know a multiplication rule yet. So I'm going to write this out twice, expand these brackets. Okay, so I'm doing FOIL. I'm going to go first outsides, insides, and then last. So 3x times 3x is, 9x squared. And then I'm going to have minus 6x over x squared. I'm going to have that again. And then I'm going to have plus 4 over x to the 4. I'm sorry, I just realized I made a mistake here. This is actually a 3 and I've used it as a 2 here. Okay, so I made a mistake. I'm going to fix that. So this is actually supposed to be a 3. And it's a 6 because these are 3s here. And I just wrote it wrong. Okay, let's clean that up. 9x squared, I'm going to have minus 12x to the negative 2 and 4x to the negative 6. Okay, now that I've done that, now I can actually take the derivative. Okay, y primed. Keep my constant. take the exponent, reduce the exponent by 1. Keep the constant. Take the exponent, reduce the exponent by 1. Keep the constant, take the exponent, reduce the exponent by 1. Clean it up. Okay, all right, let's try one more. Okay, again, I don't have a rule to deal with this yet, so I'm going to write this out. Expand this so I just have sums and differences. X squared times x squared is x to the fourth. I'm going to remember that this is actually negative 1/2 here, and I'm going to go x to the 3/2 because 2 minus a half is 1.5, and then x to the 3/2 again, and then plus 1 over x, or x to the negative 1. Let's go that way this time. Okay, I'm just going to combine like terms here. X to the 4 minus 2, x to the 3 over 2. And if this is difficult, just pause the video and do that expansion slowly. That's totally fine. Okay, let's take the derivative. Take the exponent, reduce the exponent by 1. Keep the constant. Bring down the exponent, reduce the exponent by 1. Bring down the exponent, reduce the exponent by 1. And maybe I will clean this up a bit more. So this is going to cancel. Okay. Let's try a word problem. Okay, so I want to determine the point on the curve where the tangent to the curve is this function. And I want it to be perpendicular to that line. So I've got a bunch of things that I need to do first. Okay, so the first thing I'm going to do is I'm going to take the derivative of the function, and I need this to find the slope of that tangent. So first up, I'm going to take the derivative here. I'm going to end up with 2x minus 3. Next, I want to find the slope of the given line. Okay, so this is my given line. So I just need to rearrange this so that I have it into slope y-intercept form. Okay. This says, though, that I want to have the tangent be perpendicular to this line. So a perpendicular slope is the negative reciprocal of that. So perpendicular slope will be 5. Like, because it's negative 1 over 5, so it's going to be positive 5 over 1, or just 5. Okay, now that I know what slope I want, so this is the slope I want. This is my formula for the slope. So now I want to know when these two things are equal. So my next step is to say, well, when is the function of the slope, or the derivative, equal to 5? So when is 2x minus 3 equal to 5? And so I know that's happening when x equals 4. So this question also asked for the point, so I know the x value of that point. So now my last step is to say, okay, well, where is the actual function, not the derivative, when x is 4? So now I'm going to take the original function and put 4 into it. Okay, so now I know that this is happening the point 4, 4, at the point 4, 4, the tangent is perpendicular to that line, x plus 5y equals 0. So that's my final answer. Okay, all we have to do now is some more practice. Please be sure to actually do all of these questions. They get quite tricky. Don't skip any steps, okay? Good luck.